Okay, in this last video we're gonna do a forced response analysis or a transient response analysis actually. So what we want is this transient structural model. Again, drag in and share the geometry and go into the model. So in the model, not much to say. Firstly, mesh. Apply, so we use the same mesh size and update. So you see the system is meshed. Then define the boundary conditions again. For some reason, if you want to change this, you can't share from the previous step. So now, sorry, before that, the load you want to apply on this point, and it will be components, and Z direction is 500 Newton. Alright, okay, so all these is the same. So now we in the analysis settings, there is a time step. So basically how much time intervals we want to have. So in this case, there's an auto time stepping. We want to turn that off, so we want to manually set it up. So we want to have a time step of 0.1 seconds, and our step end time we want to do maybe 10 seconds of simulation. So altogether we're going to have 100 steps. Then another thing very important is the damping. So now we want to use the damping versus frequency. Remember we said in FEM we usually have a damping related to a frequency. So let's say we want to, if for 5 Hertz, we want to have 0.05% damping. Alright, then lastly we want to define what we want to plot. Again, firstly total deflection or total deformation, and then now we want some deformation. So we want to plot deformation. We want to have a look at deformation on this point, and we want in Z direction. Also probably we want to look at a bending bending moment. Sorry, this one. So we want a beam bending moment. Sorry, what we really want is this beam results. Then we want a bending moment. So in the geometry, we want to choose this beam, apply, and we want to have another bending moment, being result, bending moment of this beam. Okay, alright, that's pretty much all we want, and we can solve it. It's take a slightly longer time than the previous ones because this is kind of a direct solution. Alright, so if we look at the total deflection, we have this. So if we play the video, you can see how the vibration is doing. That's pretty much probably too quick. So you can see there is a few, at least two natural frequencies or modes being excited mainly. So that's the first and second mode, and you can see that the amplitude of the vibration is slightly damping now, and also you can see this bending moment, total bending moment of these top beam and side beams. Sorry, this is because this is absolute value, so there should be actually a like a sinusoidal wave, but because it's absolute value, so it come back again. So these two bending moments actually help you to identify which mode is being involved in this vibration, because remember in the first mode and second mode, what kind of bending happen in those beams, so you can kind of identify which mode is involved in. So that's your force vibration sample. Thanks a lot.